Hi, Mrs. Bricky here. This is Math 1050 section 4.4, Properties of Logarithms. There's 4 topics in this section. The first topic is change of base for logarithms. So our calculator has a couple of log buttons. It has this button log and this button ln. So the log button is base 10 log and the ln button is base e log. But sometimes we need to evaluate a different base, like log base 3 of 15 right here. So if we need to know about approximately what this is equal to, we can use this change of base formula. Now, this is a formula that is not on your formula sheet, so it's just one that you need to know. But if you have a log of any base, you can change it into a different base, and it's the log of that different base of the argument over the log with that other base of the base itself. And sometimes this formula is hard to look at and determine, but a couple of examples I think make this really clear. So what we would like to do is change it either into base 10 or into base E, because we have calculator buttons for those two bases. So I could evaluate this in my calculator as the base 10 log of 15 divided by the base 10 log of 3. So it's the log of the argument over the log of the base. And so if I did that in my calculator, this would be the log of 15 over the log of 3. So we changed it from a base 3 log into base 10 logs so that our calculator can evaluate it. And we get 2.465. Just watch how it asks you to round on this topic when you do it. I can't remember how many decimals, but that's 3 decimal rounding. So I chose base 10 here, but I could have also done this as natural logs and changed it into base E. So natural log of 15 divided by natural log of 3 gives me exactly the same answer. So as long as you use that same base both in the numerator and denominator, it'll work either way. So you can kind of do whichever one you prefer. So that is called the change of base formula. It's the log of the argument over the log of the base. Now, notice that there are 2 logs here. This is way different than the quotient rule. So the quotient rule is for, the log of a quotient, and then you could expand it using subtraction. This is a log divided by another log. So these, the quotient rule and the change of base rule are just 100% different from each other. Okay, so here's the actual official topic. So the topic, says round to the nearest thousandth. So if I wanted to do log base 1/3 of 1/7, I usually do natural log just because. So this would be the natural log of 1/7 over the natural log of 1/3. Again, if you prefer, you could do base 10. And I just when I'm doing something like this, I like to just use the division symbol instead of the fraction button, but you could do it with the fraction button as well. So this one, rounded to the nearest thousandth, would be 1.771. Log base 5 of 4, if we needed to evaluate that in our calculator, we would do the log of 4 divided by the log of the base. And so this one would give us 0.861 if we round to the nearest thousandth. You can get a negative answer here if you did log base 4 of 5, if I just switched those two numbers, that would be the natural log of 5 over the natural log of 4. Sorry, this is totally not going to give me a negative answer. If we did something like the log base 3 of 1/8, something like that would give us a negative answer. So log 1/8 over log 3. Yeah. So don't be surprised if you get a negative answer. Negative answers are totally possible. Okay, the next topic is just the base properties of logarithms and using them. So this first, so we've got 5 properties, and these properties are on your reference sheet. So our first property we've already used a little bit, log base b of 1 is 0 for any base, and log base b of b is 1 for any base. The 3 properties we're going to focus on here are these bottom 3. The log of a product is the sum of the 2 logs. So we can expand multiplication into the addition of 2 logs. Log base b of a quotient becomes a log minus a log. And if we have a log of something to a power, you can bring the power down as a coefficient. So those are our 3 properties, and you have studied logs before, so this is kind of just a quick review of these properties. So our first problem says we have 2 logs that we want to add together. So our addition property of logarithms tells us that we would multiply those arguments together in the single log. So we would multiply the 5 and 7, so this would be the log base 9 of 35. Here we have a log subtract another log, and it's equal to the log of the fraction 4/3. So if you look at this log property here, you can see that we need a 4 in this spot. So it would be the log of the top minus the log of the bottom. So we need the 4 there. And then this rule is this last property, it has a coefficient right now. We want to write it as a single log, so we're going to bring that coefficient up as a power. And we can evaluate that 2 squared. 2 squared is the same as 4, so this would be the log base 7 of 4. Remember, those log properties are on your reference sheet. So something that we sometimes have to do with logs is expand them. So we have a log of, kind of a complicated little argument here. We want to expand it so that it does not have any exponents, and each log should have only one variable. So the first thing you might notice is that we have a quotient here, so we can apply this property and use some subtraction. So this would be the log of the top minus the log of the bottom. And so now that we've applied that property, we've got a power here, so we can apply this power rule and bring that power down. So this would be the log of y minus 4 log z, and that would be your final answer. We have no exponents, and we have only one variable in each log. So we've got one more to practice here. This is the log of y to the 8th power times x. So we have a log of a product right here. We're going to expand it using addition of logs. So this will be the log of y to the 8th plus the log of x. So I used the multiplication there. And then we can apply the power rule and bring that power down. So it's 8 log y plus log x. That would be our final answer. No exponents, just like we needed, and only one variable in each log. Okay, so that's called expanding. Our last topic says writing an expression as a single logarithm. This is sometimes called condensing. So when you're condensing, the first thing I usually look for is powers. and the powers show up as coefficients. So the first thing I like to do is bring my powers up. So that's going to be a third power here, and this is going to be a fifth power. And so what I have now is log base b of y minus 2 to the third power minus log base b of y plus 7 to the fifth power. You don't need to multiply those powers out or anything. Obviously, we would not like to do that for a fifth power. And now we have a log subtract another log, so we're going to condense that to be the log of the quotient. So there's just one log here. It's the log of the first over the second, so it's just a single log. The y minus 2 to the third goes on top, and what we're subtracting, this log that we're subtracting, that argument goes to the bottom. Y plus 7 to the fifth. And that would be your final answer. We've written it as a single logarithm. So here's one where we have 3 logs that we want to condense. So again, I like to start by bringing my powers up. So this is going to be a fourth power. This is going to be a 1/4 power. It's okay that it's a fraction. And that's going to be a second power. So our expression looks like log base 7 of y to the fourth minus log base 7 of w to the 1/4 plus log base 7 of z squared. So I've got my powers up now. So when you're looking at the addition and subtraction rules here, when we write our final log, we're going to have the log of a fraction. Any positive logs are going to go to the top of that fraction, and any log that's being subtracted, that argument is going to go to the bottom. Don't get into situations where you have weird compound fractions. Just any positive log, the argument goes to the top. So this is a positive log with an argument of y to the fourth, so I have y to the fourth in the numerator. This is a negative log of y to the 1/4, so that argument w to the 1/4 goes to the bottom. And this is a positive log base 7 of z squared, so that argument z squared goes to the top. So any positive log, the argument goes to the top of the fraction. Any negative log, the argument goes to the bottom. And we can use that idea here with these natural logs. First thing is powers up. So that 2 is going to become a power squared. The 3 is going to be a third power. So we have the natural log of x minus the natural log of y squared minus the natural log of z to the third. So like I said with the last example, it's going to be the natural log of a fraction because we've got some negatives there. Any argument from a positive log goes to the top. Any argument from a negative log goes to the bottom. And then this last log is also negative, so that z to the third goes to the bottom. And that's our final answer. Okay, so that's it for section 4.4. If you have questions as you're doing your topics this week, let me know. Thanks.